Welcome to the online class, children. We are going to do our next topic, atmospheric pressure and winds. So children, please take out your books and we will continue with the lesson 13, page number 109. Introduction, concepts of atmospheric pressure. We are surrounded by air on earth, but we do not see it, yet we can feel the pressure of air. Thus, air pressure and wind are invisible elements of weather which influences other components of weather, that is temperature and humidity. The variation in the air pressure from place to place occurs due to differential heating of the atmosphere. This causes the movement of winds which serve as means of transporting heat and moisture from one region to another region. Thus, air pressure is crucial to all forms of life on earth as it plays a dominant role through its control over temperature, variation and precipitation. Children, atmospheric pressure, we can feel the air pressure on the earth when the pressure is getting influenced by the weather conditions, and the pressure from place to place occurs. Pressure of different of heating of the atmosphere take place. This causes the wind, which serves as a means of transporting moisture from one region to another, is called air pressure. Let's see the concept of air pressure. Like any other material object, the air also has weight. It is also having weight. One can feel it while driving or walking against the wind. This is because air is a mixture of gases. Gas molecules are in a constant state of collision and move freely. If we keep a gas in a closed vessel, its movement is restricted by walls of the vessel. Thus, gas molecules exert an outward push as they dash against the container. Similarly, the atmosphere may be deemed to be a closed container bounded by the land and sea from below and force of gravity from above that does not allow air to escape to outer space. Air pressure therefore can be defined as the force exerted against the surface by continuous collision of gas molecules. The amount of pressure exerted by air at a particular point is determined by two factors, namely temperature and density. Since air pressure is proportional to density as well as temperature, it follows that a change in either temperature or density will cause a corresponding change in the pressure. It can be described as pressure is equal to density into temperature. Therefore, an increase in either density or temperature will cause an increase in pressure. The atmosphere exerts a pressure of about 134 gm square centimeter at sea level. This amount of pressure is exerted by the amount at sea level on all human beings, plant, animal, rocks, etc. We do not feel the atmospheric pressure because the air inside us exert an equal amount of outward pressure, balancing the inward pressure of atmosphere. Air pressure decreases with increasing altitude. As we are going upward, it decreases. And it is at a certain height, this balance is distributed, resulting in marked physiological distribution such as nose bleeding, ear bleeding, etc. Mountaineers have to face a lot of difficulty because of such reduced atmospheric pressure at great heights. This is so because the higher we go, the thinner becomes the atmosphere. The molecules in the high altitude are more diffused and pressure reduced. The atmospheric pressure is measured more accurately with the help of a mercury barometer. The rise and fall of the atmospheric pressure is indicated by the corresponding rise and fall of the mercury column in the glass tube. Children, that is the measuring balance with which we take atmospheric pressure in the barometer. The atmospheric pressure is measured accurately with the help of mercury barometer. The rise and fall of the atmospheric pressure is indicated by the corresponding rise and fall of mercury column in the glass tube. The standard sea level pressure is given in 113 MB at a temperature of about 15 degrees C at latitude and 45 degree north. This pressure is equivalent to 29.92 inches or 76 millimeters of mercury. Pressure gradient. The degrees of pressure between 2 points along a line perpendicular to the isobar divided by the distance between the points is called a pressure gradient. In other words, pressure gradient is the rate of change of pressure per unit horizontal distance. It usually means a change in a direction perpendicular to the isobars. Isobars draws closely to on the weather map represent a step pressure gradient, while isobar drawn farther apart indicates a weak pressure gradient. Pressure gradient affects the velocity of wind as air wind moves from high pressure area to the low pressure area. The velocity of speed of wind depends on the pressure difference between the two places. Wind speed is more when pressure gradient is more or steep. Wind speed is less when pressure gradient is less or gentle. Factors affecting air pressure. We have already seen that the air has weight and therefore it exerts pressure. This pressure is not the same in all regions. Atmospheric pressure depends primarily on three factors: altitude, temperature, Earth's rotation. Children, we are going to see influence of altitude on pressure. It is a well-known fact that pressure decreases with an increase in altitude. On an average, the air pressure decreases at the rate of about 34 millibar per 300 meters of altitude. The air pressure is low in the upper layer of the atmosphere as compared to lower layer. This is because the air is composed of gases and thus is highly compressible. The lower layer of atmosphere are compressed and denser as compared to upper layer. Moreover, when air rises up, the molecule gets farther apart and upward pressure decreases. Whereas in the lower layer, in the compressed state, the molecules of air get closer together and outward pressure increases. It is therefore follows that when air sinks, its pressure increases. In sinking, the volume of air decreases, but number of molecules remains the same as they are in a compressed state. Thus, the outward pressure of these molecules is confined to smaller area, hence the layer of air is dense. On the other hand, when air rises, its volume increases and it expands and the pressure decreases. As we go higher, atmospheric pressure decreases because of the air in a lower layer of the atmosphere is dense than a higher level. This is because of gravity or the magnetic pull of the earth, which attracts the molecules of the air and the atmospheric gas downwards to the ground. The upper layer rests on the lower layer, thus exerting pressure on the earth's surface. Influence of temperature on pressure. Temperature is inversely proportional to pressure. It is because with the rise in temperature, air gets heated and rises up. See figure 13.2. As it expands, it increases a low pressure area when temperature is low and air becomes heavier and denser. Children, please see this diagram and make it and follow it and try to understand it. Influence of rotation of earth on pressure. The rotation of the earth causes air at the poles to be pushed towards the equator. There is high pressure on the poles because of the low temperature. Because of rotation, the air coming down from the poles occupies more space and expands and its pressure falls. These low pressure belts are along parallel of 90 degree north and 60 degrees south. Also, air always moves from high pressure towards the low pressure. Therefore, as air moves away from poles, air moves in from the higher level to take its place. The Coriolis force and its effect. So children, till here we will read and we will continue in the next part of the video. Thank you children for your cooperation. We will meet in the next video. Thank you.